In this video, we are going to be talking about complementary and supplementary angles. Complementary and supplementary angles are common angle relationships in geometry. Let's explore their differences. First up, we have complementary angles. The relationship between complementary angles is that they are two angles that add up to 90 degrees. Below here, I have a diagram showing you a right angle that has been split into two. Since we know a right angle has 90 degrees, these two angles here have a sum of 90 degrees. It's important to note, though, that complementary angles do not have to be adjacent, meaning they don't have to share the same vertex like they do in this picture here, right? Those two angles have the same vertex. They could just be two separate angles. And let's say I came up with measurements. Let's say that's like 42 degrees and this is 48. Those are considered complementary because they still have a sum of 90 degrees. Over up top here, for an example, I showed two numbers that add up to 90 degrees, but they also form a right angle. So I have a 60-degree angle and a 30-degree angle. And then a quick tip to help you remember that complementary angles have a sum of 90 degrees. If you write out the word complementary, and I'm just going to take the highlighter here, and I take that C and I kind of just turn that into a 9. And then right next to it, I have the O, which we're going to interpret as a 0. That's our reminder that complementary angles have a sum of 90 degrees. Supplementary angles, on the other hand, are two angles that add up to 180 degrees. In my first diagram here, I have what's called a linear pair. A pair always indicates two, right? A pair of socks means you have two socks. So here I have two angles, and they're form a line. They're on a line, so I know that these two are a linear pair. And what I'll often do is I'll draw a semicircle on them to remind myself that they have a sum of 180 degrees, since a semicircle has a sum of 180 degrees. If I want to draw two supplementary angles that are not adjacent, one example we could think of is, let's say I think about a rectangle. In a rectangle, if I look at these two angles here, these are like the consecutive interior angles. If I take a look at them, they both have a measure of 90 degrees, so therefore their sum is 180, and they are supplementary to each other. Okay. Up top over here, I drew an example of a linear pair again that are supplementary using 120 and 60. And the supplementary tip is a little bit of a stretch, but if I go along with our complementary, where we kind of reinterpreted the C and the O as a 90, right? We traced over it. I could do something similar here. I could put a 1 up front. I could make this S kind of connect it into an 8. And I can turn the O into, or I create an O from the U. So this would be our reminder of 180 degrees. Let's take a look at some examples and sample questions using complementary and supplementary angles. First up, what is the complement of a 56-degree angle? Well, we know that if they're complementary, they have to add up to 90. So what I'm really thinking about here is I'm doing 90 minus 56, and I get a measure of 34 degrees. For the second question, what is the supplement of a 56-degree angle? Well, since supplementary angles add up to 180, I'm going to subtract from 180 this time, and I get 124 degrees as my supplement. Over on number 2, I have a very similar question, just some numbers swapped out. The complement of a 45-degree angle is also 45 degrees, since those two numbers have a sum of 90. The supplement of a 45-degree angle would be 135 degrees, since 180 minus 45 gives me 135. In the next set of examples, we're going to first decide if the angles shown in the diagram are complementary or supplementary, and then we're going to find the measure of x. So over in number 3, I see that little square indicating I have a right angle. I want to think, okay, a right angle has 90 degrees, therefore complementary. And now using that information, I'm going to subtract 62 from 90, and x is 28 degrees. Over on number 4, very similar diagram, except this angle, the right angle, has actually been bisected here because yes, we have complementary again, but when I solve for x, I get 45 degrees. That's how I know the right angle has been bisected, because it was split into 2 equal parts. Over on number 5, I have a linear pair, so I know, okay, these angles are supplementary. Remember, this means 90, so x is 90 degrees as well. You could draw that semicircle to help you remember 180 degrees as the sum. Number 6, decide if the angles shown are complementary or supplementary. Well, once again, we have supplementary angles. And this time I'm going to subtract 114 from 180, and x is 66 degrees. Okay. Now let's take a look at a couple that require a little bit of algebra. So number 7 says 2 complementary angles are in the ratio 2:3. Find the measure of each angle. So the key thing we first want to look at is, are we talking about complementary or supplementary angles? We see the word complementary. I know somewhere in this problem that I'm going to have to use 90 degrees. So let's just recap what a ratio is. A ratio is just a comparison of 2 numbers. And when we're given ratios, we're usually given them in a reduced format. So 2:3 is in its simplest form, that ratio. But another example is like 4:6. Those 2 values, they're still comparing 2 numbers, 4 and 6, but the reduced version of that would be 2:3. For instance, another one, 20 and 30. Those are 2 values that when I reduce them, I get that same ratio of 2:3. So what this problem is really asking us to do is find 2 angles that if I reduced them, I'd get 2:3, but they also have a sum of 90. So the way I like to do this is, when I'm given this ratio here, 2:3, I really like to interpret those angle measures as 2x and 3x. And we'll talk about how x relates once we solve for it. But if I know, okay, they're complementary, I'm going to say 2x plus 3x equals 90. And now I have a rather simple algebra equation to solve. 5x equals 90. And when I solve, I have x is equal to 18. So the problem does not say find x, right? We introduced that ourselves. We have to find the measure of each angle. Well, we said that one of the angles was 2x, so 2 times 18 gives me 36 degrees. We said the other angle is 3x, so 3 times 18 is 54 degrees. And those are our 2 angle measurements. And we can see 36 and 54 do actually add up to 90 degrees. Now, let's say I wanted to check that a little bit and make sure that those angles, 36 and 54, are actually in a 2:3 ratio. I'd encourage you to think about, can you find the greatest common factor between 36 and 54? Okay. And if you can't find the greatest, any factor will work. If we do the greatest common factor would be 18. If I divide those values by 18, I get 2:3, so they are in that 2:3 ratio here. All right, for our last problem, write and solve an algebraic equation given the diagram below and find the measure of each angle. I see my linear pair. Linear pairs are supplementary, so they add up to 180 degrees. So I know that I'm going to do 2x minus 9 plus x plus 3 equals 180. When I write my equation, I just drop those parentheses and degree signs, by the way. Let's combine like terms. I have 3x minus 6 equals 180. And let's work to isolate the variable. And I have found that the measure of x is 62. When I want to find the measure of each angle, if I go to my picture, this angle over here was x plus 3, so 62 plus 3 is 65 degrees. Over here, this is 2x minus 9, so 2 times 62 minus 9. That gives me a measure 115 degrees. If I wanted to check, 115 and 65 do add up to 180, so therefore these 2 angles are supplementary to one another. Hopefully this helps you understand complementary and supplementary angles.